Hello, welcome to this video. This is second video on lesson 5-6, the essentials of calculus, and we are going to talk about discovering the fundamental theorem of calculus. Okay, so without further ado, a goal we want to discover the fundamental theorem of calculus. Let's go ahead and look at some cases and see if we can kind of conjure up the fundamental theorem of calculus. So number 7. It says here is a graph of the derivative of f of x, and they want us to calculate the definite integral from 0 to 5 of f prime of x dx. So essentially what they're asking us is they want the area under the curve of f prime of x from 0 to 5. And again, that's this area here. Okay, well that's just a simple calculation. That is 5 times 3, and 5 times 3 is 15. Okay, so there is that definite integral. They want us to write an equation for f prime of x on that interval 0 to 5. Well, this is a constant function, f prime of x, and the output is just 3. So there's our function. And now they want us to go ahead and find f of x if f of 1 is equal to 4. Well, I have the derivative. If I want the equation, go ahead and integrate. So I'll take the integral of f prime of x dx, which is the integral of 3 dx. So this is going to be 3x plus c. Okay, so that's what f of x is equal to. So I know though that f of 1 is equal to 4. So they're giving you a point. So if my function 3x plus c is equal to 4 when x is 1, I can go ahead and identify c. So we get c is equal to 1. Okay, so that just means that my function f of x is equal to 3x plus 1. Okay, so there's our function. All right, now what we're going to do in D is they say, okay, what is f of 5 minus f of 0? So if I just evaluate this function, okay, I have 3 times 5 plus 1, that is 16, minus f of 0, so 3 times 0, which is 0 plus 1, that's 1, and this is equal to 15. Hey, notice this, right? Part D, it is equal to part A. Okay, let's go ahead and look at example 8. In example 8, they're going to ask us kind of the same type of things. They want you to find the area from -2, which is here, to 1, which is here, of f prime dx. Okay, well, that's 1/2 of, okay, this height is -2. Times -2 times the length, which is 1. Okay, so that's 1 plus this area, okay, which is 2. So 1/2 times 2 times the height, which is 4. Okay, so we get -1 plus 4, which is 3. Okay. Part B, write an equation for f prime of x on 2, 1. Well, this is a straight line, right? You have a y-intercept at 2. So this is y is equal to, well, I'll use notation. F prime of x is equal to 2. And then the slope, right? I'm rising 2 over 1, so that's just 2x plus 2. Okay? They want you to find f of x if f of 1 is equal to 0. Well, we're going to go ahead, in order to find f of x, I'm going to take my derivative and I'm going to integrate. So this gives us 2x squared over 2 plus 2x plus c. So x squared plus 2x plus c. Now they do tell us that f of 1 is equal to 0. So if I set this equal to 0 and I plug in 1, we get c is equal to -3. Okay, so f of x is equal to x squared plus 2x minus 3. Okay, so I have my function, and then D. Now they want us to go ahead and to find the displacement. So from f of 1 to f of negative 2. So we'll go ahead and plug this in. We get 1 plus 2 minus 3, and I'm going to subtract f of negative 2. So that would be 4 minus 4 minus 3, okay? And we get 3 minus 3 plus 3, okay? And not 0. Sorry, I'm thinking about the first part. We get 3. Hey, what do you know? Again, we have 3 is equal to 3. Okay, and there's kind of a pattern going on here, right? We have the integral of derivative, okay, and that value is being equal to the displacement of that definite integral, whatever those values are. Okay, so let's go ahead and look at one more example in context. Here we have a function, position function, x of t, and it wants us to find the displacement of the object on the interval 4 to 1. So if I go ahead and plug in what is x of 4 minus x of 1, this gives us 9/2. You can believe me. Okay, 9/2. Part B, find the velocity equation v of t. Well, I'm given the position. I need the velocity, so I'm going to go ahead and I'm going to take the derivative. Okay, so that is negative t plus 4. So there's my velocity. Okay, they want us to sketch this. So here's 4. Rise negative 1, run 1. Rise negative 1, run 1. Whoa, I'm off here. Why can't I draw a straight line? So 4. Okay. Much better. Just took a couple of tries. There we go. So here is our line. And they want us to, that was C, to now find the area under the velocity curve from 1 to 4. Find the integral. Okay, so here's 1. Here is 4. So they want all of this area. Well, again, this is equal to 1/2 times length times width. So 1/2 times the length, which is 3, the width or the height, which is 3, and we get 9/2. Hey, so notice again for all of these, the values for A and the values of D are equivalent. Okay, and that brings us to the fundamental theorem of calculus. So we have some conditions. If f prime is a continuous function on the closed interval a to b, then the integral from a to b of a derivative of f prime of x dx will be equal to f of x evaluated on that closed interval a to b. Okay, so f of b minus f of a, right? And this is just pretty much saying, the fundamental theorem of calculus is saying that if I have a derivative, if I evaluate on a closed interval, that will be equal to the displacement of a function. Okay, that's discovering the fundamental theorem of calculus. In the next video, we'll talk about some examples. All right, catch you next time. Peace.